Hi, everybody. As promised, I wanted to go over the section 5.2 worksheet with you. I just downloaded it, and there it is. So problem number one, M&M plain candies come in various colors. According to the M&M/Mars Department of Consumer Affairs, the distribution of colors for plain M&M candies is as follows. 21% of them are purple, 19% of them is yellow, 21% of them are red, and so on. Suppose you have a large bag of plain M&M candies and you choose one candy at random. Find the probability that you get a green candy or a blue candy. So this is an OR, and as we learned in class last night, OR means add. So this is going to be equal to the probability of green, which is .06, because 6% of the candies are green, plus the probability that candy is blue is 0.08. And now I can simply add these because these are, we're about to say in the next part, these are mutually exclusive outcomes. So yes, it is impossible to pull out a candy that is green and blue. It's only possible to pick out a candy that's one color. So these are mutually exclusive events. Part B, pretty similar. Find the probability of yellow or red. We're just going to add 0.19 and 0.21. So that's going to be 0.4. As for the probability of not purple, we can use the formula that we learned for complement. So this would equal, this would equal 1 minus the probability of purple. So the probability that I get a purple candy is 0.21. So part C would be 1 minus 0.21 or 0.79. Alternatively, you could have added up all of the probabilities of the non-purple candies. They should all add up to 1. So adding up these ones over here would get you to 1 minus the 0.21. Okay, let's see. The next problem asks, let me move this down to its own page. You draw 2 cards from a standard deck of 52 cards without replacing the first one before drawing the second. Now, okay, I still got plenty of time, only 3 minutes in. The thing cuts me off at 10 minutes. You draw 2 cards from a standard deck of 52 cards without replacing the first one before drawing the second card. Are the outcomes on the 2 cards independent? So if I'm not replacing the card after, I would say that the answer to this question is no. And that's because what I get on the first card impacts the probability of what I get on the second card. So the probability of say, king, given I pulled out a king, maybe I'll separate this, king on the second, given that I pulled a king on the first, is not equal to, I don't know how to do strike throughs of equal signs, so I'll say exclamation point is not equal to the probability of pulling a king on the second pull, if I don't know what I pulled out first. So the probability changes depending upon what happens first. So maybe better to put that into words. So no, because the first card impacts the probability of what gets pulled second. And we'll see that in part B, the probability of a 3 on the first card and a 10 on the second card. Well, first I want to multiply. First, the probability that I get a 3 on the first card. So there are 4 3s in a deck of cards, and there are 52 cards altogether. So that's the probability that I get a 3 on the first card. And then I want to multiply that by the probability that I get a 10 on the second card, given that I pulled out a 3 on the first one. So the deck has been changed. There's only 51 cards left in it, and there are 4 10s in there. So the probability of getting a 10 on the second card, sorry, the kittens are going nuts, is going to be 4 divided by 51. The number of wins is 4. There are 4 10s in the deck. The number of ways is 51. I removed a 3 from the deck. So this equals, I think, 16 divided by 2652. And that might simplify, but don't worry about simplifying. WebAssign doesn't care, neither do I. Part C, samesies. It's going to be the probability that I pull a 10 first is going to be 4 divided by 52. And I want to multiply that times the probability that I pull a 3 on the second card, given that I pulled a 10 on the first card. Given that I pulled a 10, there are 4 3s left in the deck, and there are 51 cards total. So I'll get 16 divided by 2652. All right, and then in part D, find the probability of drawing a 10 and a 3 in either order. So the in either order is kind of saying what's the probability of pulling 10, then a 3. I'm going to use multiple parentheses here. Or 3, then a 10. And I can just add these probabilities. So it's going to be basically my answer from part B plus my part C answer. And I don't have to subtract here because it's impossible to simultaneously pull a 10 followed by a 3 and pull a 3 followed by a 10. So I can just add those two numbers together. Now when we add fractions that have the same denominator, we just add the top. So I'll add 16 divided by 2652 plus 16 divided by 2652, and I'll end up with 32 divided by 2652. All right, so I hope that that's helpful for you all. If you have any questions, please feel free to hit me up in the help requests. Talk to you soon.